All right, Unit 5, Analytic Applications of Derivatives. We've got the mean value theorem of the VTs. The MVT is the only one that it is needed to be both continuous and differentiable. IVT and EVT just need continuous. Okay?
If everything's continuous, continuity applies differentiable.
And what it means is if you take the average rate of change between the endpoints, there has to exist some point in between where the slope of that tangent line is the same as the average rate of change or the secant line. And Rolle's theorem is just mean value theorem where you just turn it flat. If you went from this point to this point where it's flat, there's got to be a maximum or minimum somewhere in between.
Oh, no.
Extreme value theorem. Here you need it to be continuous. And this is where we check all of our candidate points. Have to check the endpoints and your critical points. And then you make a chart, plug them in. The highest number is your extreme max. Your lowest one is the minimum. If our derivative is positive, our original function is increasing. If the derivative is negative, your original function is decreasing. First derivative test, I'm going to add to this here. We're starting off with the idea that f prime of c is equal to 0. If f prime changes from negative to positive, then you would know you have a minimum. If f prime changes from positive to negative, you have a maximum. If it keeps the same sign, then you're going to have a stationary point of inflection. How to find concavity. I sometimes don't like the word test with concavity because people get it confused with the second derivative test. The first derivative test and the second derivative test both find maximums and minimums. Most people see second derivative test and think concavity. That is not true. We do use the second derivative to say whether the original function is concave up or concave down. So if the second derivative positive, concave up, second derivative negative, concave down. And if the second derivative changes from positive to negative, you have a point of inflection. But the second derivative test says another way you can find a minimum is knowing that it's equal to 0. So this first part is the same with the first derivative test and the second derivative test. But then instead of seeing that it changed from increasing to decreasing, you just find the concavity at that same point. And if something is concave up and the first derivative was 0, the only possibility is the minimum. If you draw concave down and the first derivative was 0, the only possibility is a maximum. And it's another way of finding maxes and mins. And sometimes on multiple choice, they'll be like, I wonder if you still remember the second derivative test. So they design a question where you can't use the first derivative test. You have to use the second derivative test to determine whether it's a max or a min.
What type of question would ask you?
So they let's say I give you a bunch of information, like if I told you somewhere in the question,
What's going on?
yeah, the board is being weird. I don't know, something like this. I give you a bunch of information, right? 3 comma, that's kind of annoying, eh? Oh.
What?
3,7 is a local max, 3,0 is a local max, 3,7 is a local min, 3,0 is a local min. It doesn't seem like there's enough information because you don't know the function. You can't tell if it's increasing or decreasing. So if you only know how to find local maxes and mins with the first derivative test, here you'd be in trouble. Okay? This part is necessary to be a max or a min. Okay? The fact that it was negative right here tells me that it's concave down. This would tell me that we are going to have a maximum. Where's the maximum? At the actual point, 3,7, not 3,0. Now, in the actual multiple choice question like this, they would also tell you that it's continuous and differentiable, but you don't actually get the equation. Sketching graphs. So we're going to look at the domain, look for any non-permissible values, try to find x-intercepts and y-intercepts algebraically if we can. If we have non-permissible values, we might have asymptotes. We might look at end behavior to see if there's any horizontal asymptotes. Find your first derivative and your second derivative to find concave up, concave down, find increasing, decreasing, find maximums and minimums. Because we can find our critical numbers, and critical numbers are not just where the derivative is equal to 0, they're also where the derivative is undefined, or at any non-permissible values. And then we graph the function with all of that information. Now this never comes up on a long answer. Instead, they say, are you really skilled at graphing things that we can take you in the middle of graphing and ask you a specific question about what's happening? So we'll see some of those. And then there's optimization problems. Find the maximum area of a suitcase. This is one we did in grade 12 pre-calculus. You have a carry-on suitcase, the length, the width, and the height can only be 100 centimeters. And we know the width is 2 times the height. What is the maximum volume that you can make given those restrictions? So that's where you take the information and you write, well, I want to find a maximum volume. So what's my volume equation? Length times width times height. What other equations do I know? I knew that the width was twice the height. And in the end, you're going to substitute all of your formulas together so you hopefully get only one variable, which you can take the derivative, set the derivative equal to 0, because that's how you find a max or a min, and you'll be able to answer the question. So optimization problems are usually just tricky in the setup. Once you've got your equation set up, you just have to take the derivative. Okay, let's do some questions. What is the value of x at which the maximum value of this occurs on this closed interval? What are we using? Extreme value here. What do we have to check? We have to check the endpoints and any place where we have critical points. If this was long answered, you would have to state that polynomial functions are continuous so we can use the EVT. Okay? If you're going to use the EVT, MVT, IVT in a long answer question, and even if you don't know how it's continuous, state it. Oh, it's continuous, so I'm going to use it. Like, okay. Maybe they're like, we can't give you the whole mark because you didn't explain why. But sometimes they're like, okay, good enough. So look at our derivative, factor it. Okay. Does anybody see how in this multiple choice you could have used the answers in the multiple choice to cheat while factoring?
Yep.
Like, I'd be like, the 3 halves and 5 halves are there. So maybe I would go with those as my first trial and multiply it out and see if it works. Some of the multiple choice are very long. And then you have to plug in all of those values and see where their answers are to determine that the biggest one is at 52/3 when x is 4. Sometimes your multiple choice is what? Average of 3 minutes per multiple choice?
It's 2 minutes.
2 minutes in other sections?
3 minutes.
Okay. But that doesn't mean that they will be equally timed. They're not trying to make them all 1 minute and 30-second multiple choice questions. Some of them will take you 3 to 4 minutes, and another one will take you 5 seconds.
I like that.
All 5-second ones? Yeah.
I don't know if I can do this kind of like math in my head.
You can, but then you're not going to be going for those high
I don't
fours.
know, 16. Maybe with the
I don't know what I meant. Yeah, you guys are the high four.
Okay. What?
Table above gives selected values for the twice differentiable function f. If it's twice differentiable, it's continuous. Continuous does not imply differentiable, but differentiable always implies continuous.
Neutral line is always
What does this make you think of?
IVT.
This one is the derivative one. It's gonna be MVT, the mean value theorem.
I hate that one so much.
Okay.
They gross it up.
In which of the following intervals must there be a number? So what's frustrating here is that if it's true on this one, we have to find the slope in here. The slope in there, right? That's our MVT. It's finding that secant line slope. So from 0 to 2, you get -1. And of course, they almost never make, if you're going to guess and check, they almost never make the first one the one that works. If you're going to guess and check, I would actually recommend starting from D and work your way backwards. You'll find the answer most likely quicker, except in this situation, because B is true.
I went with B.5.
If I find the average between 2 and 4, that slope is -2, therefore the mean value theorem comes into place. If we did check the other ones, one is 6 and one is -1. So the answer is going to be B.
B is always the right one, which one's the ones.
Usually it's C or D.
Don't work it out. I always feel like I did like 2. I think that's right. What?
I guess it depends on the level of checking. If there's a lot involved in the checking, maybe they start making it more B. There's not a lot involved in checking. They usually make you wait to the end.
B, D, C, A.
Yeah, no.
B, D, C, A.
Yeah.
Right? There we go.
Yeah.
It's going to be our new acronym for these kind of questions. It's a BDACA.
Oh, I can remember that.
There was B.
Doesn't remember anything else, but has a strategy for guessing. Function f given by this, concave down. What does that make you think of doing? Second derivative. Is that hard to do?
Yep.
No. Second derivative, 6x minus 4. Set that second derivative equal to 0, you get 2/3, and if you draw your number line, we plug things into f double prime. It's positive to the right, negative to the left, concave down before, concave up after. So it's going to be c from negative infinity to 2/3. Here we have the graph of g prime. The derivative of the function g is shown above from -2 to 4. When is g increasing? No, when is g decreasing? So if this is g prime, and I drew a number line here for g prime, I have possibly 0. Does it touch 0 at 2? Maybe. I'll put that in there as a maybe. And g prime is actually positive here, then negative, then negative. So this means that our g of x graph would be increasing, then decreasing, then decreasing. All the way up to 4 and back to -2. So of these answers, it's decreasing from 0 to 2, the and from 2 to 4. The only thing that works for that is decreasing from 0 to 4. I guess we don't know for sure it hits there exactly. It might be negative the whole time.
I'm gonna get a little too.
High zero. Zero.
It's almost a 1.
Don't deserve a 1.
We did not
No, we
know
did not.
that.
The scale is actually 1 to 5. So
Okay, what am I gonna hide?
very low one. It's like when you're given a grid of numbers, but you don't have numbers in between them.
Exactly.
So you can't say for sure it's
Okay,
increasing
well,
all
if
the
I get
time.
or I get a 1 4 or 5 and don't like
Or clearly nice.
you do everything you know, sign it.
You're wrong. You're wrong, but you keep fighting.
Table values of a differentiable function, so we know it's continuous. Based on the table, which of the following statements about f of x could be false? I always find these ones, I always sigh a little bit. These are going to take you longer, right?
No.
Could be false, must be false. We know it's continuous, so all of our IVT, MVT, EVT functions come into play. There exists a value c such that f of c equals 1. Before we get too far, what theorem is this going to be? IVT. This one's IVT. Second one, exists a value c such f prime of c is 1.
NVT.
That's MVT. Exists a value c such f of c equals -1, IVT again, and this one is another MVT. Okay. A is true. Do you see that if you go from 6 to -2, you will hit 1, right? If you go from 6 to -2, you're going to have to hit 1. Okay? Sometimes what I find helpful in these questions is, right? 6, -5, draw that point in blue. 6, -5. I've got 0, 4. And I've got 3, -2. Oops, negative 5.
Oh,
There we go.
I crossed that.
Negative 5 comma 6, sorry. Negative 5 comma 6, starting there, 0, 4, and then I've got 3, negative 2.
Term -5.
And all of those points have to be connected by some graph. I don't know what that graph is. It could be nice and straight through them, or it could be
It still passes.
like that, I don't know. The first one
What's before negative?
says, if I go from 6 down to negative 2, I for sure will hit 1. Okay?
BDCA, God, go guys.
For B,
What else?
But you see, that's what I'm saying, my method works.
your method's working today. There exists a value such that f prime of c has to equal 1. Well, in order to check the mean value theorem, you actually have to figure out the average slopes in both of those sections and the whole section. 3 of them to check. So the whole, this first section has negative 2/5. From 0 to 3, that section has an average rate of change of negative 2, and over the whole thing has an average change of negative 1. Using the mean value theorem, those are the only slopes we can guarantee. It's possible that you could have other slopes, obviously. Look at what I drew. I basically have every slope possible. But those are the only ones that are guaranteed with the mean value theorem. So that's why B could be false. Why C is true with the intermediate value theorem, because -1 is still in that range from 6 to -2. And using the outside values, D has to be true with the mean value theorem. So, as a look at that question, we'd be fine. Mean value theorem is kind of annoying that you have to check so much, right? The intermediate value theorem is really easy to check. There's a graph of f. Which of the following is true? So I see in the answers f of 1, f prime of 1, f double prime of 1. How do I figure these things out? Well, f of 1 I can figure out. That's equal to 0. In fact, that is the only thing that I know for sure. But when I look at f, do you see that f is decreasing? So even though I don't know what f prime of 1 is equal to, since the graph is decreasing, f prime of 1 has to be less than 0. In fact, f prime of x is always less than 0. F double prime tells us about concavity. Do you see that this is concave up? So f double prime of 1 has to be bigger than 0 in order to have that concave up. And then it's just a matter of which of those work.
Oh my god.
But this is not a guess and check one, so this doesn't fall into
I
your...
had to check them all, so it's like a.
It's kind of.
Yeah.
If you're guessing, you should go with it.
No, sometimes, no.
What do you say?
I had to redo them all to see the order, so. Yeah, let's go.
The function f is the antiderivative of the function g, defined by g of x equals e to the x minus natural log of x minus 2x squared. Ugh, right?
Yeah.
Which of the following is the x coordinate of the location of the relative maximum for the graph of f of x? Okay, those look like calculator values. So I would probably say, hey, throw it into your calculator.
There's a calculator symbol.
And there's a calculator symbol. Throw it into your calculator and find the maximum. Now, f of x, f of x the derivative of f of x is equal to g of x. So if we want to find a maximum of f of x, we would need f prime of x to equal 0, which means we need g of x to equal 0. And then in order to be a maximum, does it make sense that g of x has to go from positive to negative? So on your graph, right? On my graph, if I have the 0, I need my g of x graph to do something like this. Because then it's changing here from positive to negative. Again, it's multiple choice. You can just look at your graph and see that. And you'll get the answer is A.
Second choice.
Oh. That's been carried on.
You just got your
Oh.
shit.
Second choice.
Oh my god, you don't know how to use it.
Second
These are
choice.
log sums.
Two. The little left.
That's what I'm doing. That's what I'm doing.
No, you press and have one. No.
Thank you.
G of x is a differential function. G prime of x is bigger than 0. That tells me right away that g of x is increasing. G double prime of x is less than 0. That tells me right away that g of x is concave down for all values of x. It is known that g of 3 is 2 and g of 4 is 7. Which of the following is a possible value for g of 5?
And we need to cook.
Okay? So what we have as a so far is 5, 10, 5, 12, 5, 14, and 5, 16. From 3, 2 to 4, 7, I've drawn it concave down, I've drawn it increasing. Does increasing imply to all of those values? Yes, they'll all be getting bigger. Right? But taking those values, we still need to be concave down. Okay? I cannot, like, for example, if I try to connect to the red point, I turn to concave up. If I try to connect to the purple point, I turn to concave up. Now, that's just viewing it. How do we prove this exactly? Okay? G double prime of x being less than 0 also tells us that g prime of x needs to be decreasing. If we figure out the average rate of change in between these two, it's 5. That's the average slope. That's this line right here. If we figure out the average slope between each of these, if we find each of those average slopes, okay, we know that our derivative needs to be decreasing. So it has to be less than 5.
Average rate of change.
Average rate of change. If I go to the blue one, my average rate of change there would be 2.5. As soon as I go to the red one, my average rate of change is 5, which is exactly the same, and it's no longer decreasing. And I wouldn't even have to try the green and the purple one because they're steeper lines. So we know that the answer has to be A. You've never guessed this one in a million years.
I actually did guess that.
You didn't use your system.
I know, but I thought the rate of increase must be decreasing or whatever.
Yeah, that makes sense.
Cause it's concave down, you know?
So it has to be
Like the slope is getting less.
These
as it goes
questions,
on,
these questions where you're gonna have to check things, usually it's either the big one or the small one, not one in the middle. Because if it fits for one in the middle, it means it fits for either above it or below it as well.
You have to put it big.
It's way
Wait,
different. Yeah, that makes sense.
Exactly.
Can't show my face.
Yeah.
That makes sense.
What's that?
Like did the rate of increase and decrease.
The rate,
Concave down.
concave down.
Well, no, but like the slope, like I know that the slope is getting less as I go along.
Yeah. So this curvature has to continue, which has to keep it to the lower one. Alright. F is continuous. The graph of f prime is shown, on which integrals is f increasing. This is a very happy one. This is one that takes you 5 seconds. 0 to 2, because you need this to be positive, here it's negative, that means it's decreasing then increasing.
I hate graphs.
Okay, sometimes you'll get those quick ones. What is the minimum value? So we've got EVT, we've got a polynomial function, so it will be continuous. We have to check our candidate points and the endpoints. So we find our derivative, set it equal to 0, get plus or minus 1. Then it's just a matter of seeing which one is the minimum.
I think you should have told shot on this person was because you just walked past.
Wait, who?
I don't know, like, that was a lot of crashing.
Maxwell thinks it's your support on the skaters.
You want to go check on him?
He's okay.
He's okay.
He's fine.
There's a chair right there.
He might have fallen off.
Yeah, no, anything but that.
All right, our first long answer question.
And I'm like, it's not my group. I'm not finding anything.
Let d of x be the vertical distance between these two functions. Find the rate of change of d of x at 2.5. So 2.5 on this graph is about here. Does it make sense that the vertical distance, that's your vertical distance, would be g of x minus f of x? Okay?
Yeah.
Rate of change would mean taking the derivative with respect to time of everything, which is just g prime of x minus f prime of x. So d prime at 2.5 will be g prime at 2.5 minus f prime at 2.5. And this you could just get these values from your calculator.
You have to write all of that on the exam.
This one you would have to show that the derivative is equal to. Okay? If this one was worth 3 marks. If it was worth 3 marks. I'm gonna say it's probably 2 marks. They would give you 1 mark. It might be 3 marks. They give you 1 mark for recognizing what vertical distance means. That you're subtracting the two functions. Then they would give you another mark for knowing that you have to find the derivative. And then give you a final mark for getting the answer. Okay? If you just wrote the answer, when you made one little finger typo when you're, and this is different. They can't give you any of those previous ones.
This is
Do they
equivalent
not?
to 10 words.
I know, but is it like
half points, they don't get half.
Well, if you didn't write anything and just have the wrong number, there's nothing they can do.
The wrong,
Right?
wrong.
What if you just put the number?
If you just put the number and the number is right,
It's 4.
That
then sometimes you can get full marks. Sometimes they have things that they're like, no, we needed to see this.
There's
so a chance of
Great.
they needed it.
So just chance.
Right.
Right.
Could be the difference.
Really did right
Between a high 4 and
Yeah, I guess you're right. Could be difference between a low 4 and a high 4.
Yeah, you get
Another
you
cooling.
get 4 plus. on
This
that.
is probably the
Pies.
pie is cooling probably right next to the potato we just solved earlier. Okay.
They put it together.
Have the pie. So like
The function f of t models the temperature of the pie in degrees Fahrenheit at time minutes. When the pie is placed on the counter, the temperature was 270. That's why we don't play hot pie.
Yeah.
We play hot potato. We've got a differential equation. The line tangent to the graph at t equals 0 to approximate this, so we need to find that tangent line. What do we need to find a tangent line? We need a point and a slope. So we know our point is 0 and 270. We know our slope equation, so we just plug things in. And what are we going to plug into this equation? We know the y value, so we can plug in the 270. And we get that our slope is negative 10. We can write our equation of our tangent line.
What?
Plug things in. And 10 minutes later, you're like, maybe I could eat this pie. Find the second derivative in terms of y. What do you have to do to find a second derivative? Take the derivative of the first derivative. But the first derivative has a y in it, not a t. So we have implicit stuff. Second derivative would be, well, if I multiply this out, this is going to be negative 0.05y minus a number. I don't even care what that number is because I know when I take the derivative, it's going to be 0. So I get negative 0.05, and then the derivative of y is dy dt. This question says in terms of y, so I have to replace the dy dt with the original equation from above.
I can just leave it like that.
And you can leave it like that or multiply it up.
I will
It's
be
big
leaving it like that.
That.
We'll mark them down so I hate them. Those are so pity for me when they see how wrong I am. Mine's gonna be so easy. There is gonna be so easy to mark and be like,
Yes, and then
Why do they not care about rounding? Like, and why don't they not care about simplifying?
The reason we all
Same reason in grade 12 they didn't care about reducing fractions. They're like, you already know how to do that.
well not
Oh, they just assume that you know how to do
You
it.
assume you know how to do that. Well, check to see if you know how to do it in multiple choice, right?
Yeah.
Because if you can't simplify, the multiple choice is gonna be not so good, right?
that's
But in the long answer, they're like, you know what, that's good enough.
Wait, in the first part of the question, it says use t of 0 to approximate the temperature at t of 10.
That seems like a bad approximation, right?
Yes.
Yes, I
Why
agree.
why did we use 10 in the slope instead of 0?
Well-
you mean 270?
If we're using this to approximate it,
Yeah,
we need the point at that time,
yeah,
and we need
the slope of that point.
dy dx at time equals 0.
Yeah.
But there's no time to plug in, right?
And then the time.
But there's no time to plug in, but there is
Equation for a line.
the y
Yeah.
to do that. But I agree that time difference is huge.
What?
It's not going to be a very good approximation.
This is negative 10. I thought that was like.
Oh, you thought this negative 10 was
Yeah,
this
yeah,
10?
be really negative.
Yeah.
No, it's actually plugging in the values and that by coincidence also.
Yeah, if I give
Like
like
a
a
high
one,
one,
zero.
you get the low one, you get that.
Yeah, do you guys, do you think there's a midpoint?
Well, yeah.
Like a midpoint?
You don't know what's inside.
A trap to the side.
The trapezoidal
Yeah.
Yeah. Okay, hold on, I get a high. When you get a trapezoidal form. You get a right brain in some form.
And that would be an overestimate of my abilities.
Over.
Graph of f prime. Figure above has f prime. Derivative of f from -4 to 6, so we know that f is continuous. F of 4 is 2. On what intervals is f decreasing and concave up? Okay? So I'm just going to take this graph and I'm going to just draw a number line here and I'm going to highlight these are the points. Those are the points where f prime is equal to 0. And f prime is definitely positive here, negative here, and positive there. So on what intervals is f decreasing and concave up? I know that from 0 to 4, it's decreasing, right?
There's probably like 1 to 4.
But then if I look at f double prime of x here, f double prime of x would say where f of x is increasing and decreasing. Can you see that at -2, it's increasing and then decreasing, then decreasing, then at 1, it's increasing again, and then increasing again. So f double prime of x, I can tell is positive here, negative here, negative here, positive here, positive there. So where is this decreasing and concave up? You're right, it's going to be from 1 to 4. So what do we need to all say here? F is decreasing when x is less than 0. So that happens from 0 to 4. And f is concave up when f double prime is greater than 0. So the answer would be 1 to 4. So does it make sense that when f prime is increasing, f would be concave up? Because f prime increasing means f double prime is positive, which would then mean that the original function would be concave up.
If you spell increasing as decreasing, I think.
Not that bad.
State all x values where f of x has a horizontal tangent on the interval from -4 to 6. Explain whether it's a relative minimum, relative maximum, or neither at each of those x values. So in order to have a horizontal tangent, the derivative has to equal 0. If it's going to be a maximum, it's going to go from positive to negative. If it's a minimum, it goes from negative to positive. So when we look at our graph, I've got the 3 dots already highlighted, but we're only looking at -4 to 6 with the open intervals, so I do not have to consider the -4. Just the 0 and the 4. Can you see that you're going from positive to negative? This one is going to be a maximum. And you're going from negative to positive. This one's going to be a minimum. You can draw your number line. Drawing your number line out and drawing the positives and negatives and pluses and minuses, I think, is really important, because there's something about the graph, and I'm just going to scroll up for a second, that sometimes people see this point and see that it goes down through it, and they're like, oh, I'm going down through it, and your head will automatically think, oh, I'm going down and then hitting it, and want to say minimum. So you have to remember that drawing that number line out, that section is positive, then negative, means it's going from increasing to decreasing. Feels like that.
I think taxing is mental work. Listen to. What is that? Period 5 and 3.
We're
still late to the class. You were still late. Because I skipped a period and came for the next one late.
Because I left late.
You want to be.
No, like 5.
From your house?
Just look 20 minutes away if I speed.
You don't have 105.
Recording.
This is all alleged.
Yeah.
Meeting during the
What happens if you get stuck in the train?
My mom gave me
I
the
didn't
word.
write
That
helps.
Does she know who she's doing?
I actually do know the laws, right?
But it's
like
not
sir,
okay
can
to
you
do
do
it.
No, I'm still.
I know, so
I believe my mom's like, they have access to the school, like, the
You guys don't have that?
My mom will.
Oh, yeah.
My mom just doesn't care if I'm there or not, so it's fine.
All right, 1 to go. Here we go.
My mom said that too.
And
My
then
mom's like, just
have
think
a
of the
vacation.
We're going to math.
Consider the curve.
She went for the months after.
This definitely looks like implicit differentiation, doesn't it?
It does.
Yes, what your grade say.
Show that the derivative is equal to this. So I take ddx of both sides. ddx of 2x is just 2. But anytime you have a y, you do ddx, you do the derivative like normal, and then add a dy dx. So derivative on the right hand side, derivative normal of sine would be cos y, but then we have to add dy dx in the end. To get the dy dx by itself, move all the terms with dy dx to one side and factor it out. And then divide. And I do like these questions that say show that, because at least you know what the answer's supposed to look like in the end. I don't like the answers that say show that when everything I do doesn't make the answer look like what it should at the end.
He's like, no. He's like, no.
Determine the concavity of the curve for all points between pi and 3 pi over 2.
Do we have to do the second group?
So you need the second derivative. Oh,
I wrote it down and I erased it because I thought it was
which
such a
would be quotient rule. Keep the bottom the same, derive the top. Is this spot, look at this part here.
Yeah, that's great.
This is happy.
What about the rest?
Draw a little happy face in there. That's a 0, that makes that all go away.
In the whole question.
Minus, and then we've got a dy dx built in there over this squared. And what can we do with the dy dx? You could substitute back in the original.
Oh, they don't.
Can we leave it like that?
Okay.
Concavity theorem.
Just it's good guy.
Is this positive or is this negative?
You know.
We'll simplify it.
You can see it.
Fine,
It looks pretty
yeah,
positive.
Well, you have like 45 minutes.
Well, like
Oh my
for this
God,
question,
What's
Well,
that?
but
I can do this for the last question of the exam when I have like 10 seconds left.
Yeah.
It's concavity.
That's
What quadrant is this?
Third.
That's quadrant 3. Why is that helpful?
No, it's not.
Oh,
Cast.
positive.
Yeah, you know that sine will be negative. You know that cos will be negative. If sine is negative, would you agree the top is going to be negative?
Yes.
If cos is negative, you're going to have negative 2 minus something, which is going to still be negative. Then you cube it,
So it keeps
still negative.
Oh my god, I got it right.
So this, without doing a lot of work, you know is always positive. And you can say that it is concave up because the second derivative is always positive on that integral.